This video is applied minimum and maximum problems. So, one of the most common applications of calculus involves the determination of a minimum or maximum value. So, we're going to jump right in and look at our first example of finding a maximum volume. So, a manufacturer wants to design an open box that has a square base and a surface area of 108 square inches. So, this is the picture. So what we want to know is what dimensions will produce a box with the maximum volume. Basically, this would be what would happen if, say, they had a sheet of cardboard that was 108 square inches, and they needed to cut it so that it could produce the biggest amount of volume. They would need to know what sizes they need to cut out. So that's what we need to figure out. Now, a couple of things we need to recognize. If we have a square base, then that means this value is x and this value is x. The height, though, is not, I don't know what that is. So I'm just going to leave it as h, okay? Now, the surface area is the total addition of the four sides. So we've got this side, we've got this side, we've got this side, and then we've got the back side, right? Those four different sides, all of which have the same area, which is x times h, or x times h, or x times h, or x times h, right? They all have the same area. There are four of them, so 4xh, and then the base has a surface area of x squared, right? So our total surface area is x squared plus 4xh, and that equals 108. I don't know what this over here is, so let's mark it out and just pretend it's not there. All right, so we're given that surface area equals x squared plus 4xh. And we're trying to maximize the volume. So what's the volume of a cube? Well, not a cube in this case, of a rectangular solid. Well, it's base, which is the width, and the length times the height. Well, that's just x times h. So our volume is x squared h. Now, volume is what we're trying to maximize. Okay, so we know that a minimum or a maximum always occurs wherever there's a horizontal tangent line, which means anywhere that the first derivative equals 0. So if we take the derivative of this and set it equal to 0, we should be able to figure it out. Problem is, we have this h in here, x squared h, okay? I can only have the variable that I'm differentiating with respect to, because that's the only value that I can solve for. So I need to get rid of the h. So I'm going to have to use this secondary equation. This one is called the primary equation because it's what we're maximizing or minimizing. The secondary equation is things that are given that are let us relate the variables in our function together. So I need to relate x and h together. So I need to solve this, although it's the equals 108 that I need to solve, not the equals s, right? Because I know that we have 108 total inches, square inches. So if I'm going to solve for either x or h, which one's going to be the easier one to solve for? Well, since x is in both of them and h is only in one, the h is going to be the easier one to solve for. So we've got x squared plus 4xh equals 108. We're going to subtract x squared. We get 4xh equals 108 minus x squared. We're going to divide by 4x, and we get h equals 108 minus x squared over 4x. So over here, we're going to plug that in for h. 108 minus 4x squared over 4x. Now, I know that I have a tendency to add things that aren't there. So let's make sure we don't add any values there. So we're going to go ahead and multiply this. Our volume equals 108x squared minus x to the fourth over 4x, right? I'm just distributing the x squared through. Now I can simplify this, of course, separate it into two separate fractions. So 108 divided by 4 is going to give me 27. X squared divided by x is going to give me x. Minus 1 divided by 4 is 1/4. X to the 4th divided by x is x cubed. So now I have my formula for volume. I'm going to find dv dx, the derivative of v with respect to x. So that's going to give me 27 minus 3/4 x squared. Right, bring the 3 out, decrease by 1. Now, remember, the first derivative test to find a maximum or minimum is to take the derivative and set it equal to 0. So this gives me 3/4 x squared equals 27. Multiply by 4/3 to get rid of the fractions. I get x squared equals 36. Take the square root of both sides. I get x equals plus or minus 6. Now for this problem, it makes no sense to say that x equals -6. It makes more sense to say x equals +6. So we get that x equals 6. Now the problem asks for the dimension. So that gives me x. I need to know what h is. Well, I have a formula for h, right? So h equals 108 minus 36 over 24. So 108 minus 36 is 72. 72 divided by 24 is 3. So x equals 6, h equals 3. That will maximize the volume of the box. So you've seen this in practice. Let's actually write it down as guidelines. First thing, I can't stress this one enough. Identify all of the quantities that are given and that need to be determined. If possible, make a sketch. Okay. One of the drawbacks to our homework system is that most of the time it gives you a picture. I'd rather you not have a picture. I'd rather you not rely on that. I'd rather you be able to draw the picture yourself. So be aware that generally testing, I don't provide a picture. I want you to draw it on your own. So first thing, figure out what you got, what you need, and draw a picture. Second thing, we want to write the primary equation. And this is the equation that needs to be maximized or minimized. Volume, area, profit, things like this. Now, you might want to look over a few formulas from geometry because you never know what's going to pop up. And you need to know that they're there and that you can find them. Third thing, reduce the primary equation to have only a single variable. Okay, one independent variable. And what you're going to do is you're going to use that secondary equation to relate those variables together. Once you've done that, we're going to take the derivative, excuse me, we're going to take the derivative and find the desired maximum or minimum using the first derivative test, basically. Now this number 4 comes into play a little bit. When you get your answer, I tend to be of the camp that says go ahead and find your answers and then figure out whether they make sense, as opposed to finding the domain from the beginning and then determining whether your answers fit into that domain. I prefer to just go ahead and find all of the answers and then ask myself, well, which ones of these make sense? Okay, so let's do a problem. Which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? Well, okay. Problem here is that we need to make sure we know this formula. The actual formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared, right? That's the distance formula. The thing is, I'm saying that the point is xy, any point is xy, and the other point is 0, 2. So I can say, okay, this is just x minus 0 squared plus y minus 2 squared. And that's true for any x and y on this parabola. So I need to minimize this distance. All right, so let's start by writing d equals x squared plus y minus 2 squared, all to the 1/2 power, right? Because I know I'm going to take a derivative, so it makes more sense to have it in this form. But my issue is I do not have only one variable, right? I've got x and y. So is there some relationship between x, y that's given in the problem? Does anybody see any secondary equation that I can use? Oh, there it is. Yeah, y equals 4 minus x squared. It's given right there in the problem. So I'm going to rewrite this as d equals x squared plus, instead of y, I'll use 4 minus x squared minus 2 squared all to the 1/2. Simplify this a little bit just to make our lives easier. 4 minus 2 is just 2 minus x squared squared to the 1/2. Now, I can take that derivative. So dd dx equals, bring the 1/2 out front, x squared plus 2 minus x squared squared to the negative 1/2. Then take the derivative of what's inside. Derivative of x squared is 2x. The derivative here, I'm going to have to do another chain rule. So plus 2 times 2 minus x squared times the derivative of 2 minus x squared, which is negative 2x. Ugh. All right. Hard part is now over. We found the derivative. We need to take the derivative and set it equal to 0. All right. So let's rewrite this up here. So we've got 1/2 times x squared plus 2 minus x squared squared to the negative 1/2 times 2x. Let's go ahead and say, well, this is 2 times 2 times x, so that's negative 4x times 2 minus x squared. Okay, everybody see that? I just went ahead and multiplied this and got negative 4x and put it out front. Now, if I set that equal to 0, this is the principle of zero products, right? Things being multiplied together set equal to 0. There's no reason to try to simplify this out. So let's look at this. This is 1 over 2. I'm going to take that to the bottom times 1 over x squared plus 2 minus x squared squared to the positive 1/2, right? I just took that negative exponent and took it to the bottom. And then here I've got 2x minus 8x plus 4x cubed equals 0. You see how I just distributed that? All right, 1/2 can never be 0. So I ignore that. Here, 1 divided by anything can never be 0. I can't take 1 and divide something into it and get 0. So that leaves only this. So 2x minus 8x is negative 6x plus 4x cubed equals 0. I'm going to factor out an x and a 2. And that's going to leave me with 2x squared minus 3 equals 0. So that means that either 2x equals 0 or 2x squared minus 3 equals 0. So this gives us x equals 0. This gives us x squared equals 3/2. So x equals plus or minus square root of 3/2. Now, we can, of course, simplify this as plus or minus the square root of 3 over the square root of 2. We do root 2's, we get square root of 6 over 2. So plus or minus root 6 over 2. Now, this has given us 3 critical numbers, right? So I can do 0. I can do a square root of 6 over 2 negative and a square root of 6 over 2 positive. So I know I'm going to negative infinity and I'm going to positive infinity. So that gives me 1, 2, 3, 4 test points, right? So I need a number less than negative root 6 over 2. Well, I guess it would be handy to know what that value is. So if we say negative square root of 6 divided by 2, it's roughly 1.2. So negative 1.2. This would be positive 1.2. So I need a number between 0 and negative 1.2. So we'll negative 1, positive 1, and then greater would be 2 and negative 2. So those are the test points that I'm going to use. I'm going to erase these so I don't get confused. Now remember, these need to be put into the original function. So I want you to notice something. Right away, 1/2 is positive. This here, we've got x squared plus 2 minus x squared squared. So a square plus a square has to be a positive. The square root of a positive is still a positive. So I still have something that's positive. It doesn't matter what x is, that's still positive. So really all I care about is this value here. So if I plug in negative 2, I've got negative 6 times negative 2 plus 4 times negative 2 cubed. So that's positive 12. This is going to be minus 2 times 2 is 4 times 2 is 8. Negative 8 times 4 is negative 32. That's a negative value. That means we are decreasing, right? If I plug in negative 1, negative 6 times negative 1 plus 4 times negative 1 cubed. So that's 6 minus 4 is 2, which means we are increasing here, which sure enough gives us a minimum value for negative root 6 over 2. Now if I plug in 1, I get negative 6 times 1 plus 4 times 1, which is negative 6 plus 4, which is negative 2. So once again, we are decreasing. That means 0 is actually a relative maximum. And then back to positive 2, negative 6 times 2 plus 4 times 2 cubed is negative 12 plus 2 times 2 is 4 times 2 is 8 plus 32. Negative 12 plus 32 is a positive number, so we are increasing, which means root 6 over 2 is another minimum. So we have 2 points with 2 minimum values. Oops. So we know that this point and this point have the same, which makes sense. There should be 2 values because it's an even function. We know that the x value is root 6 over 3, root 6 over 2, sorry, and positive root 6 over 2. But we need to find the y value, right? Because it asks specifically for the points. Well, I know y equals 4 minus x squared. So if y equals 4 minus x squared, then y equals 4. What's our x? Our x is root 3 over 2, right? So minus square root of 3 over 2 squared. And I do this just because this is going to let me get rid of the square. If you ask why I didn't use this, it's just because this gives me 3 halves, right? So 4 minus 3 halves. So that's going to be 8 halves minus 3 halves, which is 5 halves. And we're going to get the same value for positive and negative because it's an even function. Therefore, our points are square root of 6 over 2, 5 halves, and negative square root of 6 over 2, and 5 halves. So if you have any questions about how to do these maximizing or minimizing problems, please just shoot me a remind or ask a question in class.